Hello.
Hello, sir.
Okay, we'll continue with physics now. We'll start off with the topic of thermodynamics. So, JEE advanced questions. So, this is JEE 2024. Um, there is a graph that is shown. This is the pressure versus time graph, and a process has been depicted like this: J, K, L, M. The arrows are like this. Question says 1 mole of monoatomic ideal gas is doing the process J to K to L to M back to J. And you have to match the quantities. So there are multiple questions and you have to match it. So first P option is work done in complete cycle. Complete cycle. Q option is the change in the internal energy of the gas, basically delta U. R option is heat given to the gas, heat given to the gas in KL, and S is change in the internal energy of the gas. Okay, delta U was in the process JK.
Okay.
And now the last option is change in internal energy delta U in process NJ. And on the other side are basically answers. Which one is which one? You have to match it. So some of the answers are RTO minus 4 RTO ln 2 0 3 RTO minus 2 RTO ln 2 and minus 3 RTO ln 2. These are the type of questions which is guaranteed marks as long as you know your basics. This is JEE Advanced 2024. So try it out and see what you are getting. You should first characterize all the processes.
Yes, sir.
It's just isobaric and isothermal, right?
Yes, sir.
Can you get the volumes for each of these points?
Yeah.
You can assume the volume here to be V naught, and then in terms of V naught, you can write the volumes at each of these points, right?
Yes, sir.
You need that because you need to find work done and all.
Hmm.
It's an ideal gas, so PV by T has to be constant.
Yeah. So at K it will be 3 V naught. At L V naught by 2 and no 3 V naught by 2. M will
At,
be
at L, it will be 3 V naught by 2,
yeah
and at M,
V naught by 2.
hmm. So now work done in this much is how much?
0. Sorry, not 0. Hold on. It will be 1 second.
Find the work done in each of the parts.
Yes, sir.
And don't make silly mistakes. These are very obvious things.
Yes, sir. 35. So,
It's an isobaric process. Work is work done.
sir, 2 or T naught.
You need to say P delta V, right?
Yes, sir.
Delta V is 2 V naught, so it is simply P naught into 2 V naught. And we know from the initial state that P naught V naught is nRT naught.
And R T naught.
And basically N is 1, so it is RT naught.
Yes, sir.
So 2 P naught V naught is 2 RT naught.
2 or T naught.
That's the work done. It is positive work done because it is an expansion.
Right.
What is the work done in KL?
KL it is minus 1 second minus
Work done in isothermal processes
uh,
nRT ln V2 by V1, right?
yes, sir.
Ln V2 is half of the V1, so ln half, so it will be minus nRT ln 2. And
Yeah.
n is 1, so minus RT ln 2, right? But T is what here?
3 T naught.
Minus 3 RT naught ln 2.
Yes, sir.
So that is obvious how we are getting it, right?
Yes, sir.
What is the work done in L to M?
L to M, it's minus 2 R T naught.
So it is the change in volume is V naught, right?
Yeah.
3 V naught by 2 to this, and pressure was actually 2 P naught, right?
Yes, sir.
So it is minus 2 RT naught, right?
Yes, sir.
Okay. And what is the work done in MJ?
MJ, R T naught ln 2.
Correct.
Yeah.
It is it is positive work done because you can see that the volume has increased here, right? It's expansion.
Yes, sir.
So the total work done in the complete cycle, this cancels with this, and this are together. So RT naught ln2 minus
3 R.
3 RT naught ln2, right?
Yes,
So
sir.
minus 2 RT naught ln2.
Yeah.
Now you have to do del U in JK. Tell me how to do that.
Uh, 1 second.
For the JK process, you have to write the equation delta Q is delta U plus delta W, right?
Yes, sir.
They are asking you for delta U in JK, so it is delta Q minus delta W. is delta U in J. Actually, you don't need to do this because we don't know delta Q. We can do
Yeah.
delta U directly is NCV delta T, right?
Yes, sir. And for monatomic CV is 3 by 2. So
3R by 2.
3R by 2.
So 1 into 3R by 2 into delta T in JK is 2T
2
naught.
T naught.
So
Yeah.
3RT naught, right?
Yes, sir.
So this matches with this.
Hmm.
Now, by the way, now that we know delta U value and we know work done value, we also know heat in this process, right?
Yes, sir.
In JK, but that is not being asked here, so we don't need to bother about
Hmm.
it.
Yeah.
Heat given to the gas in KL.
Hmm.
KL is isothermal process,
So
and
delta
we
U is
know work done there, right?
yes, sir.
And delta U will be 0.
0. So delta Q is equal to
Delta Q will be equal to delta W. The
delta
work
W.
done in KL we already know is minus 3 RT naught,
Yes.
ln2. So that answer will be this one, right?
Yes.
And Mj now, again, Mj is isothermal, so it is 0, right?
Yes.
Delta U in Mj is 0.
Yeah.
So as long as you know your basics of all of the processes and how to calculate work done and you are being careful, this type of a question is free marks always.
Hmm.
And every year you'll get one or two of them. You cannot miss out on such questions. Do you
Yes.
understand? Because
Yes.
there cannot be anything complicated. What they are testing is whether you know the processes and whether you know your basic theory or not.
Hmm.
So again, JEE Advanced 2023, the previous year, again there is a process question. The graph is shown. This is why I want you to make sure that you have done all the advanced questions on this, because unlike optics, there is no issue here. It cannot be like such a difficult question came and you cannot figure it out. In
Yes.
optics, it is possible.
Okay.
Do you understand what I'm saying?
Yes, sir.
It could be a difficult question in optics which you can't figure out in the exam. But here, it's all about just knowing theory. The question is, okay, so this is the first graph. This is process one, and another graph is shown, pressure versus V, and this is a graph like this. They can try to make it long and complicated, but ultimately they cannot make it difficult because it's a theory-based thing.
Yes, sir.
For example, here they're trying to make it very long and scare you by the data, but you just have to not get scared.
Hmm.
This is V naught, this is 2 V naught, this is process 2, and this is process 1. The question is saying 1 mole of ideal gas does two processes, 1 and 2, as shown, 1 and 2. In cycle 1, in 1, they have given information that A, B, C, D are isobaric, isothermal, isobaric, and isochoric, respectively. And in cycle 2, they have said that A dash, B dash, C dash, D dash are isothermal, isochoric, isothermal, isochoric, isobaric, and isochoric. Isobaric and isochoric. Okay, they have said this and this. Total work during cycle 1 is, okay, total work done here is W1 and total work done here is W2. And you have to find the ratio of W1 by W2.
Okay.
So ultimately, just a lot of data, a lot of information. You just have to do your basic stuff.
Yes.
It is fine to take 5 minutes and make sure that it is correct. You have 5 to 6 minutes per question. Don't make an error, get the right answer. That's the important thing.
Yes.
By the way, this 2V0 mark is supposed to be the volume of this, by the way, right?
Yes, sir.
Similarly, this 2P0 is supposed to be this side.
Yes, sir.
You have to calculate 3 works here and 2 works here, right? Because one of the processes is isochoric here and 2 of them are isochoric here.
Yes, sir.
Make sure you calculate it properly and then take the ratios.
Sir, 2.
Hmm. Answer is correct. 2 is the answer, but you could have saved like a minute on it, I think.
Okay.
Maybe it's important to be correct though. It's fine if you took an extra minute, but the answer is correct.
Okay.
Do you realize that it is easy?
Yes, sir.
You just have to make sure you don't make any silly mistakes. That's all.
Yes, sir.
Okay, another question from the same JEE Advanced 2023. 1 mole of ideal gas expands adiabatically from an initial state Ta, V naught to final state Tf, 5 V naught. Another mole of the same gas expands isothermally from initial state Tb, V naught to final state Tf, 5 V naught. Now, ratio of Cp by Cv is gamma for this gas. What is Ta by Tb? Notice that this is the same final state, both of them.
Yeah.
Same final state. What is Ta by Tb ratio? Once you start thinking of the problem, you will realize it's so easy. What are the qualities of an adiabatic process? What are the things you remember? Characteristics of adiabatic process? Can you tell me the defining equations for adiabatic processes?
PV power gamma is equal to constant. TV power gamma minus 1 is constant. And for pressure, T power gamma, P power 1 minus gamma is constant.
You don't need to remember the third one. You can derive it, right?
Yeah.
Do you know that we can derive from one of them all the others?
Yes, sir.
All you have to do is convert pressure to nRT by V, right?
Hmm.
Or convert whichever one you want to remove. You can convert it to the other one using the gas law, right? Ideal gas law.
Yeah.
I hope you understand what I'm saying.
Yes, sir.
You should remember these two because these are easy to remember.
Hmm.
So which one will we apply here?
TV power gamma minus 1.
We can say TA V naught power gamma minus 1 is equal to TF 5 V naught power gamma minus 1, right?
Yes, sir. And TB is equal to TF.
So thus directly we'll put that here TB, right?
Yep.
So TA by TB is going to come out as 5
5
power
power.
gamma minus 1, right? Because this will
Yep.
cancel.
Yeah.
So the answer is simply this, and this takes less than 1 minute. Like if you know
Hmm.
your theory.
Yes, sir.
Basically, bonus marks this is. And there is one more question also like that. Basically, there are three questions from thermodynamics in JEE 2023. In 2024, there were fewer, lesser, but another question is there, JEE Advanced 2023. A closed container contains a homogeneous mixture of 2 moles of ideal monoatomic gas lambda 5 by 3 and 1 mole of ideal diatomic gas lambda is 7 by 5. Here, the gas mixture does a work of 66 joules when heated at constant pressure. What is the change in internal energy in joules? Change in internal energy in joules.
Sir, 121.
What did you do?
Sir, so the total internal energy change will be sum of both individuals. So it will be 2 into 3 by 2 R into delta T, whatever the change is, plus 1 into 5 by 2 into
Hmm.
delta T. And then our total work, since they're both ideal gases, it will be N1 R delta T plus the other N2 R delta T. So it will become a 3R delta T, and that's equal to 66. And since the same change in temperature, I mean, and delta T is same here, we can equate delta U by N1CV1 plus N2CV2, and is equal to 66 by N1 plus N2 into R. And just solve
CV1, okay, this was the ratio. So it is 3R by 2 and all, right? 3R by
yeah,
2 and 5R by 2.
3R by 2.
So not 5 by 3. I'm making a mistake. So you will say this is 3R by 2 and this is
Yes.
5R by 2, right?
Yeah.
So basically you're getting 3R delta T and 5 by 2 R delta T. So you're getting 11R by 2 delta T.
Yes, sir.
This is your delta U, and work done is P delta V because it is constant pressure, right?
Yes, sir.
And P delta V can be written as N R
And
delta T, but N is the total moles for the whole mixture now.
yes, sir.
So that will be 3 R delta T, right? That is 66. So that gives you R delta T is 22.
22.
So you put that value here, you'll get to 121.
Hmm.
Also, by the way, you could have, that is the same solution, but you could have done it in a different way also by saying that we can find the gamma for the mixture, right?
Right. Yeah.
So we can say the mixture has a gamma which is different, which is N1 gamma 1 plus N2 gamma 2 by N1 plus N2,
Yes, sir.
right?
Yeah.
This type of situation has been shown in HCV examples in the thermodynamics chapter or KTG chapter, one of them. Just go through the examples once, at least see what he is explaining, how you get the mixtures gamma, right?
Hmm.
Once you get the gamma of the mixture, it's the same thing. You take delta T internal energy change for the whole mixture, and then you say, if the mixture had gamma of something, then what can I do, right?
Right.
Once you calculate that, then you can directly say that work done for the mixture is on 3 moles of the mix. Ultimately, it's the same thing that you have done.
Right.
So again, not very difficult. Let's go to the next one. Okay. So this is 2022. A bubble has surface tension S. Ideal gas inside the bubble has gamma is 5 by 3. Bubble is exposed to the atmosphere, and always retains its spherical shape and is always spherical. Okay. When atmospheric pressure is PA1, radius of the bubble is R1, and temperature of gas enclosed is T1. And when atmospheric pressure is PA2, radius of the bubble is R2 and the temperature of gas enclosed is T2. Now they're asking which statements are correct. First statement is, one second. First statement is, basically they are asking you to find the ratio of, okay, one second. If the surface of the bubble is a perfect heat insulator, is a perfect heat insulator, then T2 by T1 to the power 5 by 2. Okay. The question is only not very clear. T2 by T1 to the power 5 by 2 or R1 by R2 to the power 5. These things we need to find out, okay? The place from where I'm seeing the question, the options are not very clear. But try to find out these things, okay?
Yes, sir.
When the surface of the bubble is a perfect heat insulator, and the other case is if the surface of the bubble is a perfect heat conductor. Bubble is a perfect heat conductor. These are the two separate cases.
Yes.
In these cases, we have to think about what is the ratio of R1 by R2 or T2 by T1 and so on. They have given us data points of two different settings when the pressure of the atmosphere was PA1 and PA2, right?
Yes, sir.
So think about it. If it is a perfect heat insulator, what kind of process would that be?
Perfect heat insulator, isothermal.
Think about it better. That's not correct. Isothermal means
Oh,
temperature doesn't change. Is
temperature
that heat
constant.
insulator?
No, heat, adiabatic.
Heat insulator means no heat is transferred, that is adiabatic. It is
Yes, sir.
possible for heat to be transferred and temperature
It,
not to change.
right.
So that would be bad. No, that is not isothermal basically, right?
Hmm.
So adiabatic process, let's say the transition from this state to this state was adiabatic. What kind of
Hmm.
equations can we write?
We can do
This is
temp
adiabatic for what gas? Which gas we are talking about?
ideal gas in the bubble.
Inside the bubble, right?
Yes, sir.
So what can we write? What equation will we get for that?
We can use temperature volume. So TV power gamma minus 1 is constant.
We can also use pressure. We can use any equation that we feel like, right?
Yes, sir.
So if you think about it, what is the pressure of the gas inside the bubble?
Inside the bubble.
This is a bubble. This is the gas inside. PA1 is the atmospheric pressure. What is the pressure inside?
Uh, 2 PA1.
No, that means you don't know your surface tension stuff.
I'm forgetting.
Hmm. So that means your surface tension stuff is not clear. You need to know that a bubble has two layers.
Right.
It's not a drop of liquid. A drop of liquid has a single layer, right? Liquid and then outside is gas, right?
Right.
But a bubble has air that is trapped inside, and then there's a thin film of liquid, right?
Yes, sir.
And then outside there is atmosphere.
Hmm.
If you if you do the revision for mechanical properties of matter, you should know that every concave layer like this, there is a difference of pressure of 2T by R, right?
Right.
Or 2S by R, or surface tension, right?
Hmm.
Pressure inside versus pressure outside, there is a difference of 2S by R.
Yes.
Do you remember that this was somewhere you've seen this before?
Yeah.
So you should realize that if there is liquid here, this pressure of the liquid is more than the atmosphere by 2S by R, right?
Yes, sir.
And the air inside, there is another concave layer. So air inside is higher pressure than the liquid by again 2S by R, right?
2s by r.
So overall there is 4S by R, right? 4S by R extra pressure, which is known as excess pressure inside a bubble. So the pressure inside the bubble actual value will be PA1 plus this.
Yes, sir.
Do you understand what I'm saying?
Yes, sir.
So you will say PA1 plus this is the pressure multiplied by the volume would be 4 by 3 pi R1 cube, right? To the
Yes.
power gamma, which is 5 by 3, should be equal to, in the second situation, it was PA2 plus all of this stuff, right?
Yes, sir.
So you will say here it would be PA2 plus 4S by R. R. By the way, this R and all is R1 and all, right?
Yeah.
Here it will be R1 and here it will be R2, right?
Yes, sir.
And here it will be 4 by 3 pi R2 cube to the power 5 by 3, right?
Hmm.
So 4 by 3 pi constants and all will get cancelled, and this one will become R1 power 5 and this one will become R2 power 5, right?
Yeah.
So you will get the ratio of R1 by R2 to the power 5, right?
Yes, sir.
That will be equal to PA2 plus 4S by R2 divided by PA1 plus 4S by R1, right?
Yes.
Correct?
Yes, sir.
You could get similar equations for temperature and all also, right?
Yeah.
T1 by T2 equations also you can get.
Yes.
You do the exact same thing. T1 V1 power gamma minus 1 is equal to T2 V2 power gamma minus 1, right?
Yes, sir.
And V1 by V2 you will get R1 by R2 to the power gamma minus 1, and it will be cube R1 cube by R2 cube to the power gamma minus 1, right?
Yes.
Do you understand? No, nothing very difficult. So
Yeah.
in the adiabatic case, which is the perfectly insulator bubble, right? You will get the ratio of R1 by R2 power 5 in terms of pressures like this, and you can also get an equation for T1 by T2, right?
Yeah.
It will also come in terms of some radius powers and all, right?
Hmm.
Do you understand? It will come in terms powers of radius.
Yes, sir.
And powers of radius we already have written in terms of this. So if we want, we can write T1 by T2 in terms of powers of this, right?
Yes, sir.
So that is the analysis for the insulator situation, right?
Hmm.
There is another situation where it is a perfect conductor, perfect heat conductor, right?
Yeah.
If it is a perfect heat conductor, then you should realize that temperature cannot change, no then.
Yes, sir.
Basically, the reason temperature of the atmosphere cannot change, and always the bubble will be in uh, equilibrium sort of with the atmosphere, right?
Yes, sir.
Because it's a perfect heat conductor, immediately it will transfer the energy, right?
Yeah.
And come to the same temperature, right?
Hmm.
So that process would be called a isothermal process, right?
Yes, sir.
So you will say P1 V1 is equal to P2 V2 for that kind of process, and there you will write PA1 plus 4S by R1 multiplied by the volume 4 by 3 pi R1 cube will be equal to PA2 plus 4S by R2 multiplied by the volume 4 by 3 pi R2 cube, right?
Hmm.
So here, this would be an isothermal process where it's a perfect conductor.
Yes.
And here you will get R1 cube by R2 cube ratio, and this will be power 3, however, right?
Yes, sir.
And that would be again similar to what we got earlier, but this time it is power 3 here.
Hmm.
Correct?
Yes, sir.
So that is for isothermal process. The previous case was for the adiabatic processes. So this question is slightly more difficult than the ones we have seen before, because you need to know your basics of uh, bubbles and stuff. But ultimately, it's about identifying when it is a isothermal and when it is an adiabatic process, right?
Hmm.
1 second, I'm getting a call. Hold on.
Yes.
Okay. Yeah, sorry. There was a call. Fine. So what we saw in this question is just like you need to do a little bit of revision for your surface tension stuff, okay?
Okay, sir.
Make sure you do that revision. Uh, what we will do is maybe one more question we can try out. Uh, this is JEE 2022. So this is the diagram. Pressure is in kilopascal, volume is in meter cube, and like this, then like this, like this. This is B, C, A. This level has been marked as 300 and this level is at 100. And here this is 0.8. In the given PV diagram, monoatomic gas is first compressed adiabatically adiabatically from A to B, then expands isothermally from B to C. Okay. And they have given you data 1 by 3 to the power 0.6 is equal to 0.5, and also ln2 is roughly 0.7, and they are asking you for total work done in the process. Total work done in A to B to C, also work done in B to C, work done in C to A, and work done in A to B.
Okay.
It is obvious that work done in C2A is 0.
0.
We just need to find out A to B and B to C.
Yes, sir.
Adiabatic expansions, work done is given by the formula Pi Vi minus Pf Vf by gamma minus 1, right?
Yes,
Or
sir.
is it 1 minus gamma? I
One.
forgot.
Um,
It is gamma
I think
minus 1.
yeah.
Sure, no? ये सही है ना?
Yes, sir.
I have forgotten a little bit, but it is obvious how to derive it. I hope this is correct,
Hmm.
right?
Yes.
We will see if the answer comes out as negative, then it is correct. If the answer comes out as positive, it's wrong, right? Because it's
Yeah.
an adiabatic compression.
Compression.
So Pi Vi, you will calculate here, it will be pressure is 100 kPa and Vi is 0.8, right?
Yes, sir.
And
Second.
we need the Vf here, right?
Yeah.
So for that, we will do PV per
P-
gamma result, right?
Yes, sir.
Okay, so we'll say 100 0.8 per gamma is equal to 300 and something per gamma, right?
Hmm.
So we are getting 1 by 3
Power 3
is
by
equal to V by 0.8 per gamma, right?
yeah.
And gamma is what? 5 by 3.
4 by 3.
So we have to do 1 by 3 to the power 1 by gamma, right? So 3
1
by 5. So
3 by 5.
0.6. So is
Yeah.
V by 0.8. So 1 by 3 per 0.6 they have given is half, right?
Hmm.
0.8, this becomes V is 0.4, right? Correct?
Yes. Hmm.
So this volume is technically half of the volume of the original, right?
Yes, sir.
So now we will do it here. It is Pi Vi. So Pi is 100 in kPa and 0.8 minus Pf Vf 300 into 0.4, right?
Yes, sir.
By gamma minus 1. So 5 by 3 minus 1. So 2 by 3, right?
Hmm.
This is 80 and this is 4 by 10, 120, right?
Yeah.
So answer is coming negative, which makes sense. That means the formula is right.
Yes.
Minus 40 by 2 by 3. So this is 6 minus 40 by 2 by 3. So 60, right?
Yeah.
Something like this is coming, right?
Yes, sir.
And similarly, now B to C is isothermal. So now it is easy because we know the volumes and all, right?
Yeah.
This is a factor of 2, no?
Yeah.
nRT ln 2, right? And
Yes, sir.
nRT will be same as the P0 V0 value here, right?
Hmm.
Do you understand what I'm saying?
Yes, sir.
ln2 value has also been given, so it's a simple direct calculation.
Yeah.
It will be 300 into 0.4 into ln2. So that is 120 into ln2, which is 0.7. So 120 into 7 by 10, so 84. This is 84, this is minus 60. And this is 0.
Yes,
So
sir.
again, nothing very difficult. Obvious only. No issues over there in this question, right?
Yeah.
And 2022, there was another question which is slightly harder, which we will discuss in the next class. So basically, again, 2022, what I can say is 3 questions have come. And 2023 also 3 questions. 2022 questions were, one of them involved a little bit of surface tension. One of them is obvious. And another one that we'll see tomorrow or day after is going to involve a little bit of fluid stuff. Not a lot, a little bit of gaseous flow. But again, the point is you can expect 3 to 4 questions in this whole paper. In both the papers combined, 2 papers combined, right?
Yes, sir.
This is just one chapter, by the way. We are doing the chapter on thermodynamics. There is one more chapter on thermal properties of matter. Maybe that one has some other questions also. So what I'm saying is roughly 3 to 4 questions you can expect. And over the next few classes, we will discuss the different types of questions. We will not do the obvious ones. Like today we did a few of them which were quite obvious. But from tomorrow onwards, we will do the less obvious ones. Okay.
Okay.
But you need to continue with your revision plan, whatever you are doing. So I hope you are working on optics and modern physics right now.
Yes, sir.
Right. And maths, you are doing what? PNC and probability.
No, so I started with the vectors 3D.
Oh yeah, vectors 3D, and then your plan is PNC and probability.
Yeah.
Okay, fine. So tomorrow also if you are free, we can do a class on physics only. We'll continue with thermodynamics, and after that we'll see. Okay.
Okay, sir.
Next class after that will be maths.
Yes, sir.
Okay, fine. That's all for now then.
Thank you, sir.
Bye.